Hello everyone. My name is Doan, and I will on behalf of my co-author to represent my work about a hybrid retrieval approach for advancing the retrieval-augmented generation systems. So this work was conducted during the time I did my master thesis at Maastricht University and at NLC Health Ventures in the Netherlands. Yeah. So in my presentation today, I will go through 4 main parts, and starting with the introduction of our works. Yeah. So as we may know, nowadays with the rapid development of large language models, the retrieval-augmented generations, or RAG, has become the most popular method of integrating LLMs for the question answering task over the private and external documents. So the main idea of RAG is to retrieve the top relevant context based on the embedding, based on vector similarity search between the vector embeddings of query and passage, and send them to LLMs to generate the response. So thanks to the RAG mechanisms, the final response can be supported by the external knowledge and can also be more reliable because we have the evidence support by the relevant context. Yeah. So, but however, a traditional retriever in RAG usually use text embedding, which has 2 disadvantages. Firstly, the pre-trained text embedding model may not capture sufficiently the domain-specific content and presentations of the text. And secondly, the text embedding models also usually treat each document independently. So it cannot capture the provenance and the cross relationships between different passages. So therefore, our motivation of this work is to solve these drawback to enhance the retriever RAG, which is tailored to the improvement in the RAG response. Yeah. So our main contribution is the proposal of the hybrid retrieval method, in which we use the knowledge graph to represent the global relationships between documents and introduce a hybrid embedding strategy in which we combine the representation of the passage from text and graphs. Yeah, and the use case we use this work focus on the question answer task over document in the health tech domain. Yeah, so our methodology of the hybrid retriever following this diagram here. So instead of using the text embedding only, like in the traditional method, our hybrid retriever will integrate the text embedding with a knowledge graph embedding component to find a better top K, right? Yeah. So the text embedding model in this block here is fine-tuned with a custom dataset to adapt with the domain specific in the retrieval task of our use case. So to do it, we use the Sentenberg framework, which is the 2-tower architecture, like in this diagram here, for the fine-tuning process. Yeah. We use the synthetic training data for the fine-tuning, which has the format of a question and its corresponding source passage pair. Yeah. The training data is synthesized by inserting each source passage into an LLM and instruct it to generate a synthetic questions. Yeah, and yeah, this process actually helps us to save time in preparing the training set data, and yeah, by increasing the automation. Yeah. So after we have the training set, we train the Sentenberg to optimize the multiple negative ranking loss by maximizing the similarity score of the positive training pairs. Or in other words, the BERT-based model in their sentiment architecture will learn to represent the query and the passage into the vectors such that the code size similarity of them are higher if they are matched to each other and vice versa. Yeah. The next step is to construct the passage knowledge graph to represent the global connection between passage and embedding them into their vector space. So the knowledge graph in this work, we constructed following the schema, like in the figure 4 here. The schema include 5 classes and 4 relationships. In the schema, the passage class is essential, which connects to the path class to illustrate where it is located in the database, and are connected to the object class, which include the general and the medical entities extracted from the passage. Right? The object class is also extended by 2 domain-specific classes borrowed by the mesh ontology. So the mesh ontology basically is an ontology to dedicate the indexing and searching the biomedical articles. Yeah. So we use these 2 classes to extend our knowledge graph. Right. So after following the schema to build the knowledge graph, in figure 5 here is the example of our knowledge graph. Yeah. The next step is to embedding the knowledge graph into vector space such that the property of the graphs are preserved. So in this work, we use the translation embedding method, for example, the trans-E method, to learn the representation of nodes and relationships such that, for example, given the positive triple, we will learn the vector of head plus the vector of relations, what going to be approximate to the vector of the tail entities. Yeah. So this is the way we learn the embedding of knowledge graph. Yeah. So after we have the embedding from both text and the graph, then we will propose a hybrid strategy to find the top K passage. Yeah. Our strategy include 5 steps, as shown in the diagram in the figure 6 here. So in step 1, we will retrieve the top end passage based on the semantic similarity of the text embedding between question and passage. And in step 2, from the top end passage, we'll concatenate each passage, text, and knowledge graph embedding together. But instead of doing it directly, we introduce a scaling weight to multiply with text embedding so that we can control the semantic meaning level of the hybrid vector while using the knowledge graph embedding as the side feature of the hybrid embedding. Right. Next, in step 3, because the question is not modeled in the knowledge graph, so we need to approximate it. It can be done by first extract all of the entities from the question using the name entity recognition model. Right. The question is then approximated by averaging all of the passage embedding in the top end, which include all of the entities from the question, which can be formulated by the equation 1 here. Yeah. And then in step 4, we will concatenate the hybrid embedding of the query, following similar to the step 2. Yeah, we're using the same scaling weight to amplify the significance of the text embedding and concatenate with the knowledge graph embedding query. And finally, in step 5, we will retrieve the top K passage using the code size similarity between the hybrid vectors of question and the passages. Yeah. So it is our methodology. So in terms of the result, we compared the performance of the proposed hybrid retriever and the traditional method using only text embedding. Yeah. So in this experiment, we use 3 versions of the test set, which include the ground truth of question and the source passage pairs, and using the hit rates and MRR matrix to measure the performance. So yeah, as we see in the table 1 here, yeah, it's obviously showing that our hybrid retriever using BGE text embedding and 3 different knowledge graph embedding show significant improvement in terms of hit rate and mean reciprocal rank in all of 3 testing sets and in different topics. Right? We also, yeah, sorry.
1 minute. 1 minute left.
Oh, okay, yeah. Yeah, so we also compared the overall RAG performance using our hybrid retriever. The experiment was started in the 50 golden question and answer testing set, and we measured the performance by the relevancy and correctness of the LLM answer. And here's the result also show that the LLMs can generate more accurate answer and aligned better with the context given by our proposed retriever. Yeah. So in conclusion, in this work, we introduced a hybrid retrieval approach with the knowledge graph component to improve the quality of RAG. The result show that we can increase the retrieval performance by up to over 8% and also increase the quality of RAG answer up to over 13%. Yeah. So in future work, we intend to focus on extend our work with the public data set and in different domains to test the generalized ability of our methodologies. Yeah. So this is the end of my presentation. Yeah, and thank you for your attention, and I will give the stage back to you.